Good afternoon, members, and how are you? My name is Muhindo Mbarak. I'm with our main lecturer, Dr. Drake. This is our second session, second lecture, following the other one of SQL injection. In the previous lecture, we discussed about SQL injection. We first looked at what are the advantages of why do we need databases in our systems. We started with why we need systems, why we need databases, and then we went ahead and looked at how a database is positioned on a complete system. Then after there, we looked at which languages or which means do you use to communicate with the database. Then after there, we proceeded and look at different types of security issues that can lead to the manipulation of database or the unauthorized access to the database. Then among them, we looked at SQL injection. So we went deep and discussed different things that happen during SQL injection, and how we realize how it can be very dangerous to our systems, because a person can intentionally or not even unintentionally damage our database if we write weak SQL that communicate to the to the databases. Then after, we went ahead and practiced some of SQL injection. We looked at different scenarios, some that are caused when user is inserting data, when user is selecting data. Then we went ahead and looked at how we can mitigate or reduce the risk of SQL injection, where we looked at prepared statement, etc. So today we're going to look at something new. It might not be new to some people, but it's going to be, we are going to learn, at least everyone, whether it is new or not new to you. I'm going to try my best to see that at least everyone lives here while they have learned one thing or two things or more. All right, we're going to look at cross-site scripting, and it's also another vulnerability of web systems, and we're going to go deep and we see how this happens. If time allows, we do a practical test and see how our site can be tampered with using cross-site scripting. And then we shall also see how we can try or how we can mitigate cross-site scripting. So this is a list of topics that we're going to look at. We're going to start by getting the introduction about this, and then the foundation, what are the basics of cross-site scripting, and then we shall proceed and look at the definition of cross-site scripting, and then we shall look at different types of cross-site scripting. Then we shall dig into those three different types, and then we shall proceed to what attackers can do with cross-site scripting, and there maybe we can also do some little practical, and then we shall also look at the real-world cases and how we can also defend ourselves against cross-site scripting. So with that much said, I would like everyone to be attentive as we go through these notes, as we explain them and understand this particular topic. It's a topic that is not just only for classwork or to use to get marks, but it's a topic that can help you still. It can help you during your working experience. When you're out of university, you're building systems. This knowledge can still help you to make your systems remain secure. So it's not just a fully theory thing. It's theory at the same time action packed, where you use it to do practicals. With that much said, cross-site scripting is client-side security vulnerability on web. So basically, this affects web systems, uh, not compiled softwares like mobile application or Windows installable application. This type of security is basically for cross-site scripting, and this one, as you've said, it is a client-based side, not server side. If you still remember SQL, it was mainly for server side. So for the SQL injection, if you still remember SQL injection, sorry, SQL injection, for it was targeting the what? The database, all right? But for cross-site scripting, it is going to target the user or hijacking the sessions of the user and present them different things. This has been also a recent issue in WordPress websites. These days, most of WordPress websites have been attacked with that cross-site scripting. In simple terms, when you open a website, or maybe when a user opens a certain website, maybe that you developed, there is a possibility through cross-site scripting that they'll be seeing different things compared to what you actually posted. That's what you call cross-site scripting. For example, you create a website, it's for a school, and it explains information about a school, but when a person opens the website, they see totally different thing, maybe for e-commerce shop, all right, which is totally separate or different from what? From school. So that kind of attack that people use to hijack is those kind of attacks that people use to hijack sessions or websites of people, it's a problem. Is that kind of problem is what you call cross-site scripting. So it is a disaster, for it does not target the database, but it targets what the user will see. So you have your domain, you have your website going to display a certain thing that you need, but when the person opens it, we are seeing totally different things, right? So I hope you're getting a picture of what is meant by cross-site scripting, or what you call XSS. So cross-site scripting has part of what you call OWASP, and it is among the top 10 issues that are published of recent that are affecting the web system. And it's also responsible for creative and far-reaching attacks on web security history, including self-replicating worms that spread across millions of users in 24 hours. For example, even in past two weeks, I've got like 3 different websites. People are coming to report to me to help them out, while their website, they're showing different things that they did not actually put there. So it is a popular issue and people already know it. So in this lecture, we shall also cover the life cycle of cross-site scripting and how web page works, how malicious this cross-site scripting can be, or when it injects in a certain website or in your website. And then we shall also look at 3 different types of cross-site scripting. And by the end of this lecture, you should be able to explain the 3 types of XSS and also be able to identify the code pattern in PHP and JavaScript that can lead to this vulnerability of cross-site scripting. And you should also be able to demonstrate how an attacker can do what? Can exploit cross-site scripting to steal session cookies and perform different types of malicious operations on the system, on different systems. And also we shall apply outputting coding and also content security policy and different kind of defenses that you can use to look against cross-site scripting. So just like if you still remember in our previous lecture, we talked about one principle to have in your mind when you're working with systems that communicate the database. If you still remember that one principle, we said you should never ever trust the data that is coming from the user. That is the only number one condition or principle that we had in our mind in the previous lecture, that if you're going to do a system that's going to involve communication with the database, even if you're doing for maybe in-house project, maybe it's going to be managing employees of a certain organization only, even if you've done it for yourself, whatever system, that as long as you'll be accepting data from user, then you should never trust the data from user, even if you're the one going to use it. Why? Because it say that, because SQL injection can happen within, by your intention or without your what? Without your intention. You can be entering a data, you can be entering some data, and if this data is not well cleaned, it can have an SQL that can operate maybe a deletion, can do a deletion operation on the database and lose your whole data. So that is the principle that we had in the previous lecture. Never trust data from the what? From the users. Then in this lecture, before we get started even, we have also one core principle. It's almost the same. Never trust user input data. So you just need to keep this principle in your mind. Any data that enters your application from the outside, from fields, from form fields, from URL parameters, HTTP headers, cookies, API responses, must be treated as potentially hostile, right? It must be treated as potentially hostile, even if it is your own application. So this principle, it prevents both. You still remember? This principle prevents both SQL injection, as I said, and also cross-site scripting. So user input must never be written directly into a HTML page without first being encoded or sanitized. You get that? I repeat, user input must never be displayed. For the SQL, we said that it must never be passed into the database before we sanitize it or before we validate it. Okay, but for this we have said it must not be displayed, because right now for cross-site scripting we are talking about the display. It must never be displayed if this data is coming from the web portal, from the user input fields. It must never be displayed directly before we do what? Before we validate it or sanitize it. Okay, so get the difference. The other one was it shouldn't be executed directly to the database, but for this one, it should not be displayed, because you're going to look at the reason. I'm not going to tell you the reason right now. All right, so we proceed to the foundation of cross-site scripting. Okay. So before examining how cross-site scripting works, it is important to understand the technology that makes it possible. So what makes the cross-site scripting possible? If we didn't have these technologies, could we be having it? So the point is, cross-site scripting cannot happen without these following technologies. So if you're dealing with HTML, CSS, and most especially JavaScript, these are the things that users do interact with. Then you should be knowing that anytime cross-site scripting attack can happen to your website. So when you're dealing with these technologies or programming languages, then you should know that you are vulnerable to cross-site scripting. So here are the three pillars of a web page. Okay, So the whole web page stands on the following. Number one, HTML, right? I believe all of us, last time when we were about to start our lecture, I did some random interview from you members, and we did interview four ladies and 4 gentlemen, and realized that at least each member here, they're already interested in software development, and they already know basics of web programming, at least each member. So it means that when I talk about HTML, at least every member should be knowing what I'm talking about. So HTML is a victim, or is vulnerable to cross-site scripting. All right. Another vulnerable technology that can make cross-site scripting possible is what? Is cascading style sheet, or what we call CSS. This one helps in how we present data on the what? On the website, on the web page. So CSS can also be a victim of cross-site scripting. Then there is another, the mother of all, which is JavaScript. Should you call it the mother or the father? I don't know. Because this JavaScript can manipulate anything, can manipulate CSS, can manipulate HTML. All right? So can even be able to send the data to the back end. Therefore, JavaScript is also what? Is also a culprit to cross-site scripting. So you should always know this. So those 3 technologies, if they are not there, then it means that we might not be affected by cross-site scripting. But we cannot do without these technologies in programming. So we made a note here and said that JavaScript is particularly significant for cross-site scripting, since it is what? It is most powerful. As I said, it is very powerful. It can manipulate the HTML, it can manipulate CSS, it can also be able to send some data to the backend. So it means that it is the most dangerous and most powerful. It can access and modify part of the web page, and it can even be able to read cookies. It can be able to make HTTP requests to the server. It can capture the keyboard, and it can even control the browser. So such kind of a language, we have to deal with it with care, all right, with much security care. So attackers exploit this power of JavaScript by finding ways to inject the JavaScript or their own JavaScript into the pages of other users that will see. As I said, someone can inject HTML, they can inject CSS, at the same time they can inject JavaScript. So if someone can inject JavaScript in your web application, then someone can use the power of JavaScript to fight the web application itself. So here are JavaScript event handlers that can be used for attacking. So we designed this table and we're going to look at them. For example, we have the event, then what can trigger it, and the example. So for example, we have on-click event. So this on-click event in JavaScript, it listens to the user when they click to something. And here is an example of how a cross-site script can be able to be executed. So if I send this field to the user who is displaying the data on the web pages without even if the user is storing this kind of data without cleaning it, it means that the other users on that particular user can be able to access this particular button that can be clicked on, and when clicked on, it executes a malicious function. Then other events, we have on loading. This one is done when the page loads. So someone can say when this page loads, I want maybe to collect their username and password. So he injects that kind of script into your web page. So for you, when your users will try to enter username and password, this script can be able to do what? To know and also collect the information, and then it sends it to its own server. So it is that much risky and dangerous. Another event we have on mouse hover, and then we have on error, and then we have on focus, and then we have on submit. So those are different functions that attackers can use to do what? To attack the users on our web pages. So of particular note is the on error handler on an image tag with a deliberate broken SRC attribute, because the image will always fail to load. So the handler fires immediate and automatically. One user interaction is required, something like that. So we're going to look at how user input flows through a web application. Okay, so we're going to see how. So before we get into the disease, let us first see how things work first, and we remind ourselves and we understand. Then we see how that can lead into a problem. So give me 30 seconds. Just 1 minute, and we start with this chapter as we breathe. So I said that before we do what? Before we look into XSS or cross-site scripting attack, we're going to first look at how web application work real quick, and then we see, after reminding ourselves how web applications work, then we see how we can mitigate the problem, or how we can get how we can be attacked, and how we can solve a problem. So understanding cross-site scripting requires understanding the journey that user supplied data takes from the browser to the server and back to the browser. You get it? I say that for you to understand cross-site scripting, you have to actually first understand. There is difference between just knowing something and understanding something. Someone will ask you, do you know how websites work? You'll say, yes, I know. You visit a URL, and then you'll be able to you open a browser, put your URL, and then be able to access the website. And that's how websites work. And you need to be connected to internet. Yes, that person has just given you a shallow way. Yes, they know how it works, but they don't actually explain how things actually work. What we've called maybe understanding, right? So it is very crucial for you to understand how things work in order for us to know how SQL injection, cross-site scripting injection works. So if we understand how the data leaves the user's computer, which is through the input, and then how the data is received and how the data is sent back to the user's computer, then if we understand that, then we can be able to get started to know where cross-site scripting problem comes from. So this is how websites work. A user submits the data through an input source. It can be a search box, It can be a parameter through the URL, or it can be header section. If someone, maybe it can be maybe someone asking you for the first name and then the last name. So anything that you use, anything that you do that enables the computer to receive information. For example, you entering their name, or entering your school number, or entering your password, or entering anything into the browser or into the web page, then it means that you're inputting data. So that is the first problem. But we shall come to see and see how that becomes a problem. Secondly, the web server. The web server receives the request and passes the data to the what? To the server-side script, such as PHP file or processing. Okay, so once you submit your information is received by a PHP, for example, script, and processes it. Okay, so the PHP scripts may store the data in what? In database, maybe for later use. For example, you want to list people who are qualified maybe for graduation, and let's say they should enter just their names. So it means that these names are going to be first saved somewhere, then later they will be retrieved and be displayed for people maybe who are going to graduate. Okay, so it means that we shall come to that. We shall see now how that can become a problem. So the HTML response is sent back to the what? To the user. So for example, let's say maybe the HOD entered people who are going to register to graduate. He entered them into the system or into the web portal, and this data is saved what? On the database. Then later, it means that this list we have to show to students maybe who are going to graduate, so they can know themselves. So we are displaying the data. So that is the third concept. So the fifth concept is the browser renders the HTML. Okay, so it encounters a script tag in an event. So as I'm saying that, as you say that, like if you look at the journey of maybe, let's say we are going to build a website that's going to allow people to show people who are going to graduate. So it means that we shall have a space where the administrator will enter the list of people who are going to graduate. Then after, on the other side, we shall have to show the students the list of people who are going to graduate. So what does it mean? It means that one side is inputting information and the other side is viewing information. Maybe on the student portal, they are viewing if they have been listed for graduation. Now, the problem can come in if the data that was put into the system had malicious code. Let's say someone puts a code that has the word or a tag of script. So I mean that when we shall be showing the student this script, will be able to do what? The student, when we shall be showing them maybe their records, if maybe they are on a list of graduation or not, it means that if this code that we are showing to student has a tag of script, what does it mean? It means that it's going to execute a Java script. Even if it was a name or anything, but as long as it has a script and well formatted, it means that it's going to execute a JavaScript operation, which is bad. So, in cross-site scripting, the server is the server is not directly attacked. Okay, so it's just used to store maybe the attacks, and it is used as a delivery mechanism to deliver the malicious JavaScript. And say that someone can save the data that has script in the database. When the user opens this script in their browsers, the script will execute. And then to me that it is targeting the user directly on their interfaces, not the server itself. So if it is targeting the server, then that attack is another different type of attack. It's not cross-site scripting. So let's look at the source versus sink. So in security analysis, the location where and trust data enters the application is called, for example, it's called a source, okay? So a place where the application receives data, we call it a source. For example, you see this, it's a get variable. This is how it gets the data that passes through the URLs. And the location where the data is written to the output is called a sink. For example, if we say echo the query, it means that it shall be displaying that. So when you're displaying that query, that location is what we call sink. So source is the source, sink is just like destination where that data will end at the end of the day. So cross-site scripting occurs when the source reaches a sink without proper encoding in between. So that's the simple point. When a user or maybe a malicious attacker enters a malicious code in our project with our input, and then we save it, and then we deliver it to a user as exactly as how the malicious attacker intended. Then it means that we shall have been a cross-site script attacked. I hope members are getting the concept. So cross-site scripting is a client side. I'm emphasizing client side. Okay, is a client side code injection attacked in attacked in which is a client side code injection attack into or in which an attacker injects malicious script into what? Into content served by the trusted website. Okay? So when victim views affected web pages in their browser and executes these injected scripts in that context of the trusted sites, giving the attacker the same level of access to the web page as a legitimate JavaScript. And that is what we call what? Cross-site scripting. So cross-site scripting occurs when user simplified data is included in a web page and output without properly being encoded and allowing the attacker to inject or execute JavaScript within our web pages. So let's look at why cross-site scripting attack is dangerous. All right. So it bypasses the same original policy. All right. So the same original policy is a browser primary security model that prevents scripts on one website from accessing resources from another website. So by use of cross-site scripting, it can make that possible, so that it can make the opposite possible, so that a user who is using a certain specific website, but in the other side, it is fetching the data from what? From a wrong website. Okay, so that is dangerous. So another issue is code runs without full trust. So the browser executes the injection script with the same trust. With the same trust it gives to the legitimate JavaScript, including access to cookies and local storages. So what we're trying to say here is that cross-site script, it will be treated just like a legitimate script by the browser, because the browser does not know. So it cannot access anything wanted, including the cookies, the session tokens, as well as the local databases, meaning that it leaves our site vulnerable and can be able to manipulate anything if it can access all that kind of what of information. So another thing, the victim is unaware. So when a user is using your website, they will not know that this is a cross-site scripted page or nothing. They'll just see they have visited, for example, Jumia.com, but what they are seeing on Jumia.com is not actually what Jumia.com posted. And for them, as long as the URL is correct, they cannot differentiate that. The users cannot differentiate that what they are viewing is not what is not normal. All right. So also on mass impact, in its most severe, from stored cross-site scripting, a single injection script can attack the user without a view page. All right, and potentially harm thousands of people of pages. So this is how cross-site script attack works. So the attacker finds an input field or URL parameter that is reflecting back to the user's HTML. So let's say that you allow people to submit their names and then later you show their names somewhere. All right. So that kind of a field is vulnerable to cross-site scripting. So another way is the attacker injects a script payload, typically inside a script. All right, so an attacker injects another script within another script, and then only one script is being seen, yet another one internally. So the victim browser parses the HTML and encounters a script and executes it. So the browser does not mind as long as you give it anything that has right syntax. So even if you give it a script that is attacked in a malicious way, the browser will just execute it as how you gave it. Okay. So SQL injection attacks the databases. So let's look at the difference between SQL injection and cross-site scripting. So SQL injection attacks the databases, while cross-site scripting attacks the users. All right. So both from the same root cause failing to treat user input as untrusted data, but they operate at different tiers and require differences. Okay, and require differences. Okay. So let us look at the core three types of cross-site scripting. Okay. It's already found, but the problem, you guys will join late, so let's proceed until maybe until we finish this, and then we can have a short break. So here are the three types of cross-site scripting. So it's classified into three types, as I said, and they're based on how and where the injection or the injected script is saved. All right. So the first type of cross-site scripting is stored cross-site scripting. Okay, so for stored cross-site scripting is the most dangerous type of cross-site script, because for it can persist even on the online database. Okay, so every time different users can be able to access it. That's what you call stored cross-site scripting. Okay, so the attacker's malicious code payload is permanently saved on the database, and when they served to the other users, Okay, so and it's served to be very, I mean, it served to be to every user who views the affected web page. So putting the fact that can be saved to the database, it means that every user who will fetch that particular web page where that content is being displayed will also be attacked. Okay, so for this one, there's no need of social engineering that is needed. The attack is automatic, so someone can do their kind of, that's what we used to call virus. They're kind of an attack, cross-site scripting, and then you find a way how to save it on your database. Maybe you can ask them your first name, and then they get your first name, and then they send it to them. All right. On this side, you're able, as an attacker, you're able to see everything from different areas. So it can be that bad. So the server stores the input in the database without any encoding or sanitization. Okay, so if we don't sanitize the data stored in the database, then it means that we are prone to what? To cross-site scripting security issue. Okay, so every victim's browser reveals and executes the malicious scripts. Okay, so why is cross-site scripting most severe? So unlike the why the stored cross-site scripting is the most severe. So unlike the cross-site scripting types stored by cross-site scripting that needs no phishing, no malicious link, and not interested. Okay, and the payload persists until it explicitly are removed from the what? From the So let's look at the vulnerability of PHP code and how these can be mitigated. So we're going to do some practicals. I'll share with you this document, and you see how SQL injection can happen. Cross-site scripting can happen. So with that much said, let's have a short break of 5 minutes. So 15 past 3, we should come back and finalize with practicals. Let's have a short break of 5 minutes. We drink on water, we stretch, and then after 5 minutes, we come and do the last session where we're going to look at what? At practicals. Okay? At practicals of how this happens. Okay? So let's have a short break and then we come back and finalize after this session.